All right, well, good morning, everyone. On behalf of Westpoint International Consultants, I extend my warmest greetings to all of you participating in our webinar, Revolutionizing Wastewater Solutions, BioMicrobics meets Jamaica. Before we begin, I want to just take a moment and acknowledge the tremendous challenges our nation has faced in the wake of Hurricane Melissa. The devastation across Western Jamaica has been heartbreaking, and we are deeply grateful that you have taken the time to join us today, despite the hardships many continue to endure. At Westpoint, our thoughts are with everyone affected by the storm, and we affirm our commitment to be a part of the rebuilding process. We stand ready to work hand in hand with government agencies, developers, and local communities in any way we can to help restore and strengthen our infrastructure, particularly in the area of water and wastewater management. It is truly inspiring to see such a diverse group of colleagues, partners, environmental professionals, and developers gathered here today, united by a shared purpose to learn, collaborate, and explore innovative ways to make Jamaica's wastewater systems more sustainable, resilient, and future-ready. I'm thrilled to present our esteemed speakers for today. First, allow me to introduce myself. I'm Tanya Cuthbert, and I will be your facilitator for this session. Our panelists for today are Tyler Birch and Anthony Cuthbert. Anthony is having some technical difficulties at this time. However, I think he and I will be switching computers as we go through the session today. Tyler Birch is a process engineer at BioMicrobics and holds a Bachelor of Science and Chemical Engineering from Kansas State University. He is involved in research and development, product optimization, feasibility studies, and advanced process design calculations. Tyler has extensive experience in designing water and wastewater treatment systems across a wide range of sectors, including power generation, industrial facilities, municipal infrastructure, residential and commercial developments, and renewable natural gas applications. Mr. Anthony Cuthbert is a professional civil and environmental engineer with over 25 years' experience leading major infrastructure and development projects across Jamaica, the United States, and the Caribbean. He is the CEO and founder of Westpoint International Consultants and is highly respected for his expertise in sustainable, regulatory compliant water and wastewater engineering solutions across a wide range of project sizes. With such an informed group of panelists, we are in for a captivating and insightful session. So let's get started. Today's agenda, we will begin with presentations by our BioMicrobics expert, Mr. Tyler Birch. He will lead our keynote presentation on biomicrobic technologies for a sustainable future, showcasing industry-leading wastewater treatment solutions and their global applications. Following that, we will move into a presentation titled Sustainable Wastewater Solutions in Jamaica, led up by Mr. Anthony Cuthbert, CEO of Westpoint International Consultants. Anthony will speak specifically on how these technologies align with Jamaica's regulatory framework, environmental priorities, and long-term national development goals. After the presentations, we will transition into our Q&A discussion, where you will have the opportunity to ask questions directly to our presenters and engage in meaningful dialogue. We encourage all attendees to participate actively. We will then close the webinar with a brief summary and next steps, including how you may continue the conversation with Westpoint and access further technical guidance or project support. Let's just take a quick look at the main objectives for today's session. Our first goal is to gain a clear understanding of the BioMicrobics wastewater treatment technologies, what they are, how they work, and why they have become a global standard for efficiency, reliability, and environmental performance. We'll see how these systems can be tailored to Jamaica's unique infrastructure needs. Next, we'll explore how biomicrobic systems meet the strict effluent discharge requirements set by NEPA and the Ministry of Health. This alignment ensures that installations not only perform well technically, but also comply fully with Jamaica's regulatory framework, a critical factor for long-term sustainability and approval. And finally, we'll look at how Westpoint supports each stage of the process, from project design and permitting to implementation and maintenance. Our goal is to ensure every project runs smoothly, meets compliance standards, and contributes to Jamaica's drive towards more sustainable water infrastructure. By the end of this session, you'll have a strong understanding of both the technology and the local context, and how together we can revolutionize wastewater management across Jamaica. With these objectives in mind, let's now proceed with the first presentation. At this time, I would like to formally invite our distinguished presenter from BioMicrobics, Mr. Tyler Birch, to lead our keynote presentation, BioMicrobics Technologies for a Sustainable Future. He will provide an overview of biomicrobic systems, including Sanity's BioBarrier and MyFast systems, discuss their applications across residential, commercial, and municipal projects, highlight proven results and global case studies, and share how these solutions can be strategically adapted to support Jamaica's environmental and regulatory goals. Mr. Birch, please go ahead and share your screen at this time. The floor is now yours.
Good morning, everybody. It's a great pleasure to be here, and I hope everyone is doing well. Okay. So I'll go ahead and get right on in.
We're hearing you, Tyler. We're hearing you.
Okay. So I'll get right on in. Thank you, everyone, for attending. I hope everyone's doing well in light of the recent catastrophe that's happened down there. I wish you all the best in your recovery efforts and all your healing. So I'm here today to represent BioMicrobics and talk to you about our FAST and BioBarrier systems. So a little bit about BioMicrobics. We've been established since 1996. We have products in over 80 countries. We have over 90,000 systems in operation, and we have 30 plus products for stormwater and for wastewater and stormwater. We're trusted across the world, and our solutions are unique in the way that they operate and are able to assist people in treating wastewater while also taking care of the environment. So going into our flagship product, we're looking at the FAST water treatment system. A little bit of an overview for FAST. FAST products are ideal for remote and rural areas. They require minimal skilled labor for installation and minimal operator presence. They're very easy to operate. They have very low life cycle costs. The only moving part on our FAST system is the blower, and all of the wetted components will not corrode. They're all made of different plastics. They can be used in marine, residential, commercial, industrial, and municipal treatment markets. It's a robust aerobic treatment system package, which utilizes a submerged fixed film activated sludge technology. We're going to touch on that a little bit more here in a bit. It was designed with ease of operation and maintenance in mind. It's essentially an install, set it, and forget it sort of system. The way it operates, it only uses naturally occurring microorganisms, which you see getting flushed down the drain and ending up in what would normally be a septic tank system. So what is attached growth? It's something that you can refer to as fixed film. If you go to a lake or a pond and you see algae that grows on a rock, that is an example of fixed film. we use the microbials which are present in wastewater on our special media for water treatment. And that's what you can see on the picture on the left here is our media for water treatment, which has a healthy coating, what we would call biological growth, or a blanket on the treatment media itself. So the advantages for fast growth, it's very easy to start up. There's no sludge needed. Essentially, once you have it installed and start passing wastewater through it, you begin treating wastewater within 7 days and you have full treatment within 30 days. It's very simple to operate. It has very good sludge thickening and settling compared to typical activated sludge systems, which you would see in suspended growth. There's a reduced sludge production due to higher organisms which are present in wastewater. In terms of power and maintenance, compared to normal suspended growth activated sludge systems, we use much less power. Again, we only have that single moving part, which is just a blower. We can have a much smaller footprint than a typical suspended growth system due to the concentration of biological activity which is occurring on the media rather than growing within a large tank of wastewater. It handles shock loads relatively well. So a large advantage of fixed film is we can handle both small flow and high flow situations. Typically in high flow situations, the concern is that you're going to be washing out all the working bacteria out the back of the system. When we have an attached growth system, that's not something you need to worry about. It sticks in place. So we're very resilient to flow fluctuations. And again, we have a large amount of active biomass, which is contained in a smaller area. Additionally, this sort of system is supportive of ammonia removal, and it's also more resistant to temperature fluctuations due to the fixed film nature of the bacterial growth. And here's just an overview of what sort of products we offer in our FAST line. A retrofast is typically for remediation or extending the capacity of an existing septic system. A microfast is something for a single family home or a cluster of homes up to approximately 125, 126 residents. Your high strength fast is what you would see for any sort of situation where you have a higher organic loading, such as restaurants, bars, coffee stands, commercial properties, agricultural or industrial facilities with organic effluents. And on my fast, we start getting into the several thousands to hundreds of thousands of gallons per day. That's ideal for multifamily properties, subdivisions, apartments, small municipalities, or even high strength commercial properties. Here's a general layout of what you'll see once you have a FAST system installed. Similar to a septic tank, you have a primary zone, but then you have a secondary zone where you'll actually have the treatment occurring. What's important to note here is the FAST unit, which is item F on this diagram, is actually an insert which sits inside of the tank. It can either be on feet or legs, so sitting on the bottom of the tank, or it can be suspended from the top of the tank. This picture here shows it suspended from the top. The insert is actually what contains the media and has an open bottom, which allows excess biological growth to slough off of the media and collect in the bottom of the tank as sludge. That helps prevent clogging of the media and allows you to keep treating the wastewater that's coming through. And again, here is just kind of a blowout of all of the components that go into here. And again, all you're really looking at in terms of moving parts is just the blower and then the FAST system itself. The FAST system itself does have a recirculation trough, but that is completely passive. There's nothing you need to set, no adjustments, no calibration, no anything. It takes care of that all by itself. And here is a picture of what you'll see during installation. So what's important to note here is that area with the blue media, that is what would be your aerobic zone, which is actually being aerated by that airlift assembly that you see in the middle there. Outside of that, in between the liner and the concrete tank, is your anoxic area. That area is not being aerated, and that is what facilitates nitrogen removal. Going back to this slide here, you can see that the trough extends out of the airlift and goes to the edge of the liner. that is what your return is into the anoxic area. That is what's actually facilitating that nitrogen removal. So for your treatment process, your influent comes in and goes into the settling tank. The settling tank is where large debris, trash, any sort of large solids are going to sit and settle. And then the blue cylinder there you see in tank labeled number 2, that is our sanity. It's labeled as number 3. The sanity is a screen which prevents large solids, trash, anything like that from entering the actual the treatment tank. The sanity has a built-in plunger which allows you to just clean it in place just simply by pulling the plunger up and down to dislodge any accumulated solids. Any of the wastewater which passes through the sanity ends up into the treatment tank. It's going to enter and be in the anoxic zone. The airlift serves as both an aeration and a mixing device, which is going to pull in the anoxic water up through the aeration zone and spread it over the top of the media. This is where the biological activity is actually occurring in terms of BOD and COD removal. And that's where the main treatment is happening. And again, outside of that is where your nitrogen removal is occurring. Any water which passes through is going to come down through the small little channel that you see on the right of the treatment liner and then exit through your discharge. And that is going to be your treated wastewater. And again, here's another blown up image of this so you can better see exactly what's happening here with the primary zone, the treatment zone, the media, and your effluent discharge here, along with the blower and the control panel which operates the blower. Here we have a quick video which kind of shows the microfast system in action. All right, moving on. So this picture is included here because it really highlights the open bottom, which I was talking about before. That right image is the liner, and the liner has that open bottom there, and what you're seeing is the bottom of the media. So that previous video showed the really vigorous aeration. It not only aerates, but it also helps clean the media. Any sort of excess growth or heavy growth will eventually slough off of the media itself, sink to the bottom, and fall out the bottom and collect in the treatment tank on the bottom, which will eventually be pumped out once you accumulate too much and you start to impact any sort of treatment processes. So going into the sizing for the FAST system, there's 2 different ways to size this. For residential applications, you're simply picking a model which has enough hydraulic capacity. So if you're producing 300 or 400 gallons a day of wastewater, you'd be looking at a microfast 0.5, which has a capacity up to 500 gallons per day. It really is as simple as that. Our systems are designed with these parameters in mind. So any raw wastewater that's coming in for your retrofast or microfast, this is what we're looking at. BOD, which would be your biological load of 300 parts per million or milligrams per liter, your solids of 300, nitrogen of 70, and your fats, oils, and grease of less than 40. Below that, with our typical microfast system, our expected treatment performance for residential applications, less than 30 for BOD and TSS, and at least a 50% nitrogen reduction. For commercial applications, we start getting into a little bit more here. So not only are we looking at the hydraulic capacity, we're also looking at the organic capacity, which is the BOD concentration. So each of these units are rated to handle a certain amount of BOD that's coming in, which we measure in pounds per day. So we use the high strength fast when your influent BOD exceeds the standard 300 milligrams per liter, which we mentioned on the previous page for your influent conditions. So an example would be if you had 1,500 gallons per day coming in with 1,000 milligrams per liter of BOD, that's approximately 12.5 pounds of BOD per day. We would select the 9.0 model, even though the hydraulic capacity exceeds the 1,500 gallons per day, but that is what's rated for the 12.5 pounds a day of BOD. You'd have extra retention time, but that is in no way a detriment towards your treatment process. We also have the capability for additional nitrogen removal using our NitroFast and ABCN system. Our NitroFast is used to convert the ammonia that's coming in, and your ABCN is what's used for something called denitrification. So nitrification is the process of converting ammonia to nitrates. Denitrification is turning those nitrates into nitrogen gas. These units will always follow a primary treatment system, and they use specialized media, which is ideal for removing nitrogen compounds. Typically, nitrogen removal units have about the same size hydraulic capacity as your primary fast treatment unit, but will have a smaller footprint. The nitrification and denitrification processes also produce less sludge than your main fast unit for your BOD and TSS removal. Here's just a quick block flow diagram, which kind of describes different setups that you can see for nitrification or for nitrogen removal. So in your typical fast system here, this is what we're looking at for 50 to 75% nitrogen reduction. We include an additional recirculation, which will recycle the effluent coming out of your fast system back to the beginning of the system, so it has a greater time to undergo denitrification, a greater time to undergo nitrification and denitrification. For an additional, if you're including denitrification with an ABCN or a NitroFast, we're then looking down here at the second diagram for greater than 75% nitrogen reduction. With these, you can include an alkalinity source and a supplemental carbon source. Alkalinity is added as the nitrification process will actually make the water more acidic, part of the biological process that's occurring here. And the bacteria which are performing this operation work best in a pH range of 7 to 9. So you need to regulate this because you can end up with water which the pH begins to drop down into the 5 to 6 range. The general rule of thumb here for this is you require 7.1 milligrams per liter of alkalinity for every 1 milligram of liter of total nitrogen removed. Carbon, which is an additional BOD source, consider it as food for the bacteria, is added before the denitrification process. You need a BOD to nitrogen ratio of at least 3 to 1 for denitrification, and that's why we add this, to ensure that we're able to fully meet your discharge requirements. And then I already touched on this a little bit. Complementary products for fast. We already mentioned the Sanity, which are just effluent screens, or excuse me, which are just screens to prevent any sort of solids from entering the treatment tank. And we also have Lixor aerators, which are designed to reduce influent BOD by up to 50% prior to the fast system. We often see these with larger systems such as your MyFast, or they could even be installed in something like a MicroFast 9.0 if additional aeration is needed, but you don't need that hydraulic capacity. Sanities are sized based on your influent flow rate, and Lixors are sized based on the installed tank depth and your BOD loading. So going into community and municipal treatment, we begin looking at the MyFast and the MacroFit. The MyFast and the MacroFit are essentially just scaled up versions of your regular FAST modules with additional features you'd expect to see in municipal wastewater treatment systems, such as biosolid management systems. So here's a block flow diagram of what you'd see for a typical MyFast or a MacroFit process. So you have your AMS, which is your aeration management system, which is your primary aeration and screening tank. Into there, you go into the actual treatment tank, which is your MyFast with your attached growth, liners, and your media. Any sort of settled biosolids go down and can be automatically pumped out, or an operator can just turn on sludge removal pumps, which then discharge into the BMS, which is the biological management system. From there, we can decant that liquid back into the treatment process, and any of the other waste solids can just be pumped out as needed. Here's a bit of a diagram which shows how a NitroFast and ABCN can be implemented into a large community treatment system. And additionally, we are using Lixors here for additional BOD removal and aeration. So as an example, GoldenEye Resort there in Jamaica, this is a treatment system which Anthony will be speaking more about later, but it is currently in operation and it's used to treat wastewater from the resort, and it is used to produce irrigation water for water reuse. Here's another system which is currently in operation in Mexico, Tren Maya in the Yucatan Peninsula. Again, it's a project in Mexico, and it was designed and built to service a railway station. This would be treating about 50,000 gallons per day of sanitary wastewater being generated from the passengers and employees at the train station. There was a strong pressure to preserve the local ecosystem, even though this was in a very remote location, which was hard to access and hard to service. The system was designed to mitigate environmental impact on the sensitive ecosystem and is currently successfully treating the wastewater to water reuse standards. It's able to be used for toilet flushing, irrigation, any sorts of those purposes other than drinking water. This is a site which I have visited myself. This is in Arlington, Tennessee in the United States. The previous wastewater treatment system had failed, and they contacted our distributor and BioMicrobics for a replacement unit. This unit was to be servicing a newly developed community of approximately 700 homes and needed to be treating about 120,000 gallons per day, with the flexibility to expand along with the community growth, which they anticipated. A MyFast 12.0 was installed, which is effectively treating the wastewater and is discharged to a large irrigation field to support water reuse. This site right now is currently undergoing expansion, and they are using an additional MicroFast along with that as well. What's to highlight here is these are modular systems. If you anticipate growth, it is quite easy to add additional treatment units in to provide that capacity that you need. Moving on to what would be our more advanced technology would be the biobarrier, which is our membrane bioreactor. So the membrane bioreactor is very, very different compared to our typical FAST system. It operates on different principles, and it produces a much higher quality effluent. It uses a semi-permeable material, which filters out undesirable materials and produces very high quality effluent. MBRs are an established technology which have been used in municipal, commercial, and industrial wastewater treatment systems for a great number of years now. BioMicrobics has been developing and testing our own MBR technology for over 20 years now. And again, we mostly focus on decentralized applications and on-site water treatment for this technology. So membrane types, they're differentiated both by their shape and by their pore size. Their pore size really dictates the function, And the configuration, whether it be flat sheet or hollow fiber, is both a preference and comes down to the needs of the user. So the biobarrier, we are in the ultrafiltration range. So as you can see on this diagram, from left to right, your pore size increases. With increasing pore size, you begin to allow other more materials to pass through without being captured by the filter. So what we're able to remove is everything down to like DNA and viruses. So even without any sort of additional like chlorination or UV, we're able to remove E. coli and other bacteria and viruses from the water without any sort of additional treatment steps required. And what's important to note here is the pore size, like I said, it really dictates what you're able to remove. Something like reverse osmosis is even able to pull like salts and atoms out of the water. And then further down the list, you start getting down into the sands and human hairs and items like that. So this is how the membrane system works. You can consider it as outside infiltration. In between those two parallel green bars there, that's the inside of the actual membrane sheet itself. Water is able to pass through. The water molecule is smaller than the pore size, but any sort of material which is above that ultrafiltration range is rejected. So that's where your solids, your bacteria, anything like that is left behind, and all you're producing is very clean permeate. So why use an MBR over a typical fast system? This is something that we can help you decide depending on your treatment needs and your effluent requirements. Any sort of regulatory bodies might have requirements for you, and we can help you determine what product is best for your needs. So comparing this to a typical fast system, your BOD is going to be less than 5 milligrams per liter, and your TSS is going to be less than 1. Typically, we see non-detectable. It's not uncommon to see non-detectable BOD and TSS in our effluent. Your turbidity, the water is going to be essentially crystal clear that's coming out. Without any sort of disinfection, as I mentioned, you're able to remove coliform bacteria. We have the capacity to implement nutrient removal such as nitrogen or phosphorus. The effluent is suitable for water reuse, whether that be toilet flushing, irrigation, fire water, and it meets surface discharge standards, and we're able to meet the most stringent discharge standards when using this system. So along with this system, there are some cons that go along with it that people need to be aware of before they decide to implement this product. It is going to be more complex and more expensive. It does require a level of operator training and a level of understanding of the system to ensure that it's operating properly. While the fast system is essentially a set it and forget it, this system does require some maintenance. There will be a clean in place that's required, and the membranes do not last indefinitely. Depending on your influent loading and how much you're actually treating, you will eventually need to replace the membranes, whether it be 10 years or later. The treatment modules, when they're installed, they need to be installed correctly or they can be damaged. And they do have a limited tolerance for any sort of abrasive or stringy materials. So that's why we do require, when we install these, a really strong primary screening pre-treatment using whether it be a Sanity or another product to make sure that those solids do not pass through. So the biobarrier uses a flat sheet membrane module. It's fully immersed in the actual wastewater which is being treated, which we refer to as mixed liquor suspended solids in this type of system. It acts like a clarifier, as I mentioned, by separating the treated water from the actual treatment process water itself. It can treat any sort of wastewater containing degradable organics to a non-detectable level, and we do have a high strength module which is capable of treating up to over 1,500 gallons per day. And again, these are module. We can put as many of them together as we need to treat the amount of water that's coming in. Something of note here is that these operate very well with aggressive cleaning practices, which are commonly seen in medical facilities. We'll touch on that here in a moment. These do use a control panel which operates locally, but it's compatible with any sort of third-party remote alarm system. There is a dry contact alarm output which is included in the control panel board itself, which is quite easy to wire up. So some applications for your biobarrier. It's good to use in places where you have high groundwater, anywhere with small lots and poor soils, which can be difficult to discharge typical wastewater effluent onto. It's excellent for use in commercial applications with very high strength wastewater, such as restaurants, wineries, food and beverage processing. We do have a specialized model to meet the needs for wineries as they are a bit more unique. We are able to provide nutrient removal, such as nitrogen and phosphorus for sensitive areas. And it's great for, again, any sort of water reuse applications such as irrigation, toilet flushing, and fire suppression water. The model sizes for our biobarrier, they are sized pretty similarly to our FAST systems. So the standard biobarrier model is based on hydraulic flow rate, and the high strength biobarrier size based on the biological load, the BOD, and the hydraulic loading. These are the certifications we have for our residential biobarrier units. So we are certified for both nitrogen removal and water reuse standards. Here are some examples of our products both being installed and in operation. Top left here is a biobarrier unit, which is currently in installation before the tank has been filled. The top right is a food processing facility, and the bottom left is a winery project. It is worth noting that commercial facilities might want to use multiple trains to allow for redundancy. This allows for constant effluent production while one of the membrane units are being cleaned, replaced, or are in a long-term relaxation cycle. So the treatment process for this is pretty similar to the FAST system, except we're not using a liner. So your wastewater comes into your primary settling tank where it's then screened by that sanity and then passes over into what is denoted as the second zone here, which is where your aerobic digestion is occurring. We're vigorously aerating that water there to allow for bacterial treatment or biological treatment to occur. So that is more of what you would kind of see in a suspended growth system. We do have the capacity here to provide anoxic recirculation for nitrification and denitrification. That is not pictured here, but we'll be seeing that coming up. And then finally, the membrane module itself, which is listed as number 4, is filtering out your treated wastewater and then discharging it. So I mentioned aerobic digestion. That is what both the biobarrier and the FAST systems work with. In the biobarrier, organisms are suspended in the mixed liquor as opposed to the FAST system, which uses the fixed film growth. Air is supplied by coarse bubble aeration. This allows for both mixing, aeration, and to clean the membrane panels themselves on the biobarrier. The air supply rate needs to be calculated for non-residential applications. That is something that we take care of here at BioMicrobics or with your vendor or your distributor, and we'll make sure that it's sized appropriately for your needs. There's no need for the customer to be involved with calculating aeration requirements. So this is a general layout for what you would typically see in a residential application. Again, wastewater comes in, goes into the settling tank, fine solids are screened out, and then it passes over into the aerobic digestion tank there, where it is vigorously aerated, and the effluent is screened out using the membranes and then discharged. It is worth noting here that the Sanity again has that plunger available, visible for your clean in place, just to dislodge any sort of accumulated solids or anything like that, which may be accumulating or at risk of clogging the screen itself. So here are some system components that you would typically see with your biobarrier. You're going to have your blower housing and your blower assembly along with your control panel, which is what you'll also see with a fast system. Your Sanity, which is a requirement for your biobarrier, but optional for your fast system. And then what's different here is we have a filtrate pump. So the water that is screened by the biobarrier is pumped out rather than gravity flow out compared to like the fast system. You also have your filter module assembly, which contains the housing, the aeration unit, all of your clean in place requirements, your aeration tubing, any hold downs that you need for the biobarrier itself. And along with this comes float switches. These can trigger a high level alarm so you know if the biobarrier is not functioning properly and not discharging the proper amount of water, so you know that the system needs to be cleaned. Here's a little bit of a close-up view of your actual system components here. There's the CIP tube, which is the clean in place. Your support pipes, which are the hold downs to keep the unit from floating. It will float because it is being heavily aerated, so it will rise to the surface if not being held down. You have your discharge hose and your externally mounted pump there. The membranes themselves sit on top of an aeration grid to make sure that they are being scoured and cleaned. And then you have your air supply pipe that's listed over there on the right. So moving into the high strength MBR variant. These are ideal for multifamily residential systems where high quality effluent is needed. We'll be looking at some of those cases later on here. It's also ideal for commercial and agricultural or industrial facilities with high organic loading. So here we're looking at a high strength MBR for BOD, TSS, and nitrogen reduction. So this would be a standard configuration here, so we would not have an anoxic zone. This is ideal for BOD and TSS reduction. You do also see quite a bit of ammonia removal here, but we were not really going into nitrate reduction because we do not have that anoxic zone, which facilitates that nitrate reduction through denitrification. It is worth noting here that an equalization tank is optional, and this alkalinity feed is listed purely as an example of if there's not enough alkalinity in the incoming water to facilitate your ammonia removal, going back to that ratio which we touched on earlier. So I mentioned before that this system does facilitate nitrogen and phosphorus removal. We're going back into that alkalinity and carbon feed to meet those requirements. We can achieve total nitrogen concentrations of less than 10 milligrams per liter when you include the anoxic tank. The alkalinity and carbon sources are again used for process control. And for phosphorus removal, we typically include an alum or a ferric chloride chemical feed, which reacts with the phosphorus. What that does is it binds with the phosphorus and causes it to precipitate out as a solid, which is then able to be screened out by the biobarrier unit. The result of all of this is filtered effluent with low nitrogen and phosphorus content. So I briefly mentioned this before, for sizing your high strength biobarrier, it's going to be sized based on hydraulic capacity and your organic capacity, your BOD loading, which is coming in. Any sort of biobarrier which is designated with the -N is stating that it is for nitrogen removal as well. And I did mention those special winery versions which are available. So this is a sizing example of a high strength MBR with our additional aeration unit, which we can include with our membrane technology, it's called a bioaerobic. A bioaerobic is included when your BOD load exceeds your maximum BOD loading capabilities for your biobarrier. Provides additional aeration, and it acts similar to like Lixors, which helps decrease the BOD loading by increasing the oxygen transfer for biological activity. The bioaerobic really does help save costs by preventing you from needing additional membrane treatment modules for higher BOD loading. So in this example, we have 3,800 gallons per day coming in, and we have a BOD load of 20 pounds per day. We don't have a listed biobarrier unit which is rated for 20 pounds per day. But if we include a bioaerobic 2.0, which is capable of removing 10 pounds a day per BOD, we're able to go from what could have been a 9.0 plus another smaller unit or multiple 4.5 units down to a single 4.5 unit and a single bioaerobic 2.0. So again, this really does help with saving on membrane costs, maintenance costs, anything like that. So this would be your general layout for a commercial high strength MBR. It's pretty similar to your residential setup, with the only difference being you have an additional blower and then you have a bioaerobic over there on the left side of the treatment tank, which provides that additional aeration requirement. So moving into some examples here where we use high strength MBRs. They're ideal for restaurants. So in this example, we had a popular seafood restaurant in the New England area, which had a discharge of 3,500 gallons per day with your average BOD loading of 1,200 milligrams per liter and nitrogen of 120 milligrams per liter. By using our technology, we were able to have effluent come out with non-detectable BOD levels and a total nitrogen of less than 5 milligrams per liter. I did touch on medical facilities before, so we can see what was coming in, but what's not listed here is the additional compounds which may be in the water. Medical facilities tend to produce difficult to treat wastewater due to toxic substances to biological growth being contained in the wastewater itself. So it's common to have disinfectants, detergents, acidic or alkaline compounds, pharmaceuticals, or solvents in these waters. In typical treatment systems, that would be very difficult to treat, but using membrane technology, we're able to treat these sort of difficult wastewaters down to BOD levels, which are non-detectable, and a total nitrogen below 7 milligrams per liter. This is a project which is currently operating in Massachusetts. So it is a low cost, affordable living community of several townhomes. They have about 10,000 gallons per day of flow, average BOD of 300 milligrams per liter, TKN of 80 milligrams per liter. So that meets our typical residential wastewater. So you'd be thinking, why are we using a membrane system here? The thing is this community was built in an ecologically sensitive area. They're positioned very close to natural bodies of water, and there was strong pressure to make sure that no nitrogen or other compounds were exiting the premises of this community. So this system treats all black and gray water from the homes in the community. We had strict effluent requirements of less than 5 milligrams per liter of total nitrogen at the treatment unit effluent, and it had to be non-detectable at the property line, again, due to the natural water resources or natural water sources and conservation areas that are nearby. The effluent has been tested on multiple occasions since it was put in operation in 2019 and has consistently been below that regulatory threshold. At this time, the system is still operating and serves as a high-performing reference for all of our other projects with strict wastewater restrictions. And that concludes my side of the presentation. I'm going to go ahead and pass it over to Anthony, and we'll be answering questions at the end. Thank you for your time.
All right. Thank you, Mr. Burge, for that informative and insightful presentation. Next, I am pleased to invite Mr. Anthony Cuthbert, CEO of Westpoint International Consultants, to share his insights on Westpoint's vision for sustainable wastewater solutions in Jamaica. Mr. Cuthbert will discuss how innovation is shaping wastewater treatment and water reuse, as well as Westpoint's local implementation of biomicrobic technologies. On to you, Mr. Cuthbert.
Sorry about that. We're having some technical internet problems. Anyways, let's get this going. Good morning, everyone. Thank you again for taking time out of your busy schedules to join us today to learn what we have to offer. I want to take a brief moment to speak from the heart. As mentioned earlier, our thoughts and prayers remain with the people of Jamaica as we face the aftermath of Hurricane Melissa. We continue to stand in solidarity with everyone affected, those who have lost homes, livelihoods, and most heartbreakingly loved ones. In times like these, the resilience and unity of the Jamaican people are what inspire hope and renewal. At BioMicrobics and Westpoint International Consultants, our commitment goes beyond words. We're here to help rebuild and strengthen Jamaica's communities. So who we are. As we look ahead, I'd like to share who we are and how our partnership with BioMicrobics supports Jamaica's sustainable future. Westpoint International Consultants is a civil and environmental engineering firm providing smart, resilient water and wastewater solutions. As the executive distributor of biomicrobic technologies, we design and implement systems that are efficient, compliant, and built to last. Our mission at Westpoint is simple yet powerful: to provide innovative, sustainable, and compliant water and wastewater solutions that streamline development while protecting our environment. We focus on 3 pillars that guide everything we do: sustainability, solutions that tackle challenges at every scale while preserving our precious resources for generations to come; efficiency, strategies that maximize output, minimize waste, and deliver results that matter; compliance, a steadfast commitment to regulations and safety standards, ensuring public health is protected now and in the future. Now imagine how these pillars can transform water and wastewater management, creating smarter, safer, and more sustainable communities. With our mission and guiding pillars in mind, let's look at how this translates on the ground into real operational impact. Westpoint is proud to introduce 5 state-of-the-art biomicrobics plants strategically located to serve communities efficiently and sustainably in Jamaica. These plants are the Golden Eye plant in Oracabessa, St. Mary, Silver Sands in Trelawney, Bessa Living, also in Oracabessa, St. Mary, Portway 2 in Cherry Gardens, and Palm Beach in St. Anne. These 5 plants are more than infrastructure. They are living examples of sustainability, efficiency, and compliance in action, delivering on our promise to their communities and the environment alike. The biomicrobics technologies used in Jamaica currently employ 2 modular treatment types. The first being the FAST system, which stands for Fixed Activated Sludge Technology. These systems can be scaled into the following sections: the microfast, which could be used for single-family homes and small residential and commercial projects. These treatment systems treat a flow range between 400 to 9,000 gallons per day, which equates to 1.5 to 34 cubic meters per day. The population served from these systems is between 3 to 126 people. Second in line in these technologies are the MyFast system. These systems are geared for medium-sized residential or commercial developments and are capable of treating raw incoming sewage in flow ranges from 10,000 to 160,000 gallons per day, which equates to 38 to 606 cubic meters per day. These systems can also serve a population of between 147 to 2,352 persons. Finally, we have the macrofit. These systems are geared for large-scale developments and are capable of treating raw incoming sewage with a flow range of 200,000 to 2 million gallons per day, which equates to 757 to 7,571 cubic meters per day. These larger facilities serve a population of between 3,000 to 30,000 persons. All three of these systems use the same fast technology to reliably meet Jamaica's wastewater effluent requirements. The second technology that Westpoint has employed in Jamaica is the biobarrier HSMBR technology. These systems are applied mainly to small developments requiring high-quality effluent. As Tyler mentioned, these systems treat a raw sewage incoming flow range of between 500 to 9,000 gallons per day, which is 1.9 to 34 cubic meters per day, and serve a population of between 8 to 144 persons. Since this is a modular system, this allows developers to add additional treatment trains to meet flow ranges that are higher for larger developments. So now I'm going to go into some of the plants that we currently have in operation here in Jamaica. The first BioMicrobics facility constructed in Jamaica was for the Golden Eye Resort. Although Westpoint had no input in this design, this plant was accepted because of its exceptional effluent quality. This advantage adds to the resort being an eco hub that encourages environmental protection in Jamaica. This facility is a BioMicrobics MyFast system, and the effluent produced from the plant is used as an irrigation source throughout the development. The first BioMicrobics plant that Westpoint constructed in Jamaica was at the Silver Sands development in Trelawney. The design and construction of this wastewater facility came with some special requirements from the Homeowners Association for the development. The Silver Sands development boasts one of the best beaches in Jamaica. With this in mind, homeowners were looking for a solution that would not affect the quality of the ocean water in the bay. The original facility that was designed when the development was in its initial stages of construction showed signs of degrading ocean water quality based on sample testing performed by the Homeowners Association. This BioMicrobics wastewater facility that was built to replace the old plant has now been operational for 14 years and is built next to the beach bar and restaurant and very close to the ocean, as you can see in the picture. This plant, since its commissioning, has not degraded water quality in the bay, and there has also never been a complaint of odor being produced by the plant affecting patrons at the nearby restaurant. The wastewater treatment plant designed for this facility has the following attributes. It is 9.2, capable of treating 9,000 gallons per day. It has a reed bed associated with it for nutrient removal. The effluent disinfection incorporates the use of chlorine tablets. Treated effluent is disposed into a soakaway pit adjacent to the beach, and the facility has a footprint of 27 feet long, 10 feet wide by 8.5 feet deep. Upon completion and commissioning of the Silver Sands wastewater treatment plant, an effluent test result was performed to show how well the facility was performing. Based on the sample result, the MicroFast technology in conjunction with our reed bed system meets all NEPA requirements, as you all could see from this test report. The first biobarrier HSMBR membrane system that Westpoint built in Jamaica was for the Bessa development in Oracabessa. Special requirements for this project were as follows. The property is located next to a river and is on the ocean. The public beach serving the community also serves as a turtle nesting grounds. As a result, effluent quality is of paramount concern. This development had an old defunct wastewater treatment plant that needed to be demolished to build a new one. Westpoint acquired this job for the following reasons. We were able to cut the price for the wastewater treatment plant by $500,000 USD as compared to our nearest competitor by utilizing the old wastewater treatment plant reactors to house the new HSMBR equipment. We were able to also gain an irrigation permit from NEPA to use the plant effluent as an irrigation source for common area plants. Part of the old wastewater treatment plant concrete reactors were also repurposed into an effluent storage tank to store effluent produced from the new HSMBR plant. The wastewater treatment plant designed for this facility has the following attributes. The plant is comprised of two high-strength HSMBR 9.0 units working side by side. Each treatment train includes neutral removal processes. This facility has a combined treatment capacity of 18,000 gallons per day. This facility needed no reed beds to achieve NEPA requirements. The effluent, we are still disinfecting, and we use a UV system to disinfect effluent entering the storage tank. The treated effluent is used to irrigate common area flora throughout the development. And the facility has a footprint of 40 foot long, 30 feet wide by 9 feet deep. Upon completion of this facility, we took an effluent sample test, and the results show that the plant meets all NEPA requirements, hands down. The effluent is just beautiful in nature. It's non-polluting. It is so good for irrigation purposes. This is a picture of the quality of the effluent coming out of the plant. I took this sample in a used water bottle. What you're seeing here is actually what comes out the tail end of the plant. As you all see, the water is crystal clear. It looks almost drinkable, making it a valuable source of irrigation water and practicing reuse and conservation practices. The second biobarrier system that Westpoint built in Jamaica was for the Portway Phase 2 development in Cherry Gardens, St. Andrew. Phase 1 of this development utilized a standard septic tank and reed bed system. Looking at the picture on the left, you all could see that the reed bed footprint is almost the size of one of the building block units, one of the blocks of buildings. You can also look at the right picture and see how small the footprint is for the HSMBR 6.0N that was built for Phase 2. These two pictures show the space-saving requirements that developers can gain by utilizing BioMicrobics treatment products in their designs for their developments. The wastewater treatment plant designed for this facility had the following attributes. The plant was a HSMBR system capable of treating 6,000 gallons per day. Wastewater, the plant itself includes nutrient removal processes. As a result, no reed beds are required. The treated effluent is discharged into a soak-away pit, and the facility has a footprint of 34 feet long by 11 feet wide by 9 feet deep. This is a short video of the quality of the effluent from this unit. Just like a plant at Port Oil 2 produces crystal clear effluent that could be used as irrigation should the homeowners decide to implement a system. Unfortunately, that water is currently going directly into a soakaway pit. The first MyFast plant Westpoint built in Jamaica was for the Palm Beach development located in St. Ann. This development is on the ocean, and there was a concern salt air owners wanted a facility that would be sturdy enough to stand up to those elements, and they chose the MyFast system for that purpose. This is a picture of some of the fast units that have been installed into the system. This plant has the following attributes. The treatment capacity is 20,000 gallons per day. This MyFast facility includes nutrient removal processes. As a result, no reed beds are required. And the plant has a footprint of 47 feet long, 39 feet wide, and 11 feet deep. The tank also has no top slab, which allows it to gain access, visually look at the bits and pieces that are with the system. Currently, the facility has been completed, and we are waiting for the pump station to fill up the reactors to the required water level for treatment to begin. As a result, we currently don't have any effluent test results for this facility because it's not operating fully as yet. But I should have those shortly. These systems bring several important benefits to the Jamaican market. First, the high treatment efficiency. Fast systems provide around 90% removal of BOD, TSS, and COD, outperforming systems that do not utilize fixed film technology. The biobarrier MBR produces effluent clean enough for direct reuse without additional polishing. These systems are also modular, scalable, and cost efficient. A major advantage for developers is modular. Treatment plans can match the phases of a development instead of forcing a developer to build a plant at 100% and upfront those costs. By using a modular design, you're able to phase out the cost of your wastewater plant to match the treatment of your phases in the development. These facilities also utilize a smaller footprint. The concrete tanks used to house the BioMicrobics equipment require far less space than traditional wastewater alternatives. They also eliminate the need for large unsightly reed beds. For developers, this means reclaiming valuable land that can be used for revenue-generating features, more homes, additional parking, green space, or community amenities like swimming pools or pickleball court. These systems have lower maintenance and higher reliability. These systems have fewer moving parts than many competing technologies. That translates to lower maintenance costs, reduced downtime, and a longer operational life. These systems also promote effluent reuse and water conservation. One of the biggest advantages for Jamaica is the ability to reuse treated effluent for irrigation. This supports national water conservation goals, protects groundwater resources, and can lower the operational cost of developments. This approach has been mainstream in places like Central Florida for many years now, where the reclaimed water system provides a valuable and reliable irrigation source for both residential and commercial communities. Jamaica now has the ability to adopt these same practices. Now that we've looked at how biomicrobic systems are being implemented across Jamaica and its advantages to developments, I want to shift to why this matters at a national level. Ultimately, these technologies do more than treat wastewater. They directly support Jamaica's long-term water resilience. First, they help to protect our infrastructure and reduce life cycle costs. By using advanced modular treatment systems, developers avoid the high capital and maintenance burdens associated with old technologies. That means longer lasting infrastructure and more predictable operating costs. Secondly, these systems enable safe water reuse and support sustainability goals. As I mentioned earlier, both FAST and BioBarrier can produce effluent suitable for irrigation, which directly reduces the demand on Jamaica's freshwater resources. In a changing climate, that kind of reuse becomes essential. And finally, biomicrobics helps position Jamaica for the future. As our developments grow in size and complexity, we need wastewater solutions that can grow with them. Solutions that are scalable, efficient, and capable of meeting stricter environmental standards. These technologies gives us exactly that. So in many ways, adopting these systems isn't just about wastewater. It's about building a more resilient, sustainable, and cost-effective water future for Jamaica. So why does all of this matter for Jamaica? It's because modern wastewater treatment isn't just a technical issue. It's a national priority. Everything we discuss aligns directly with the country's long-term development goals. First, these technologies support Jamaica's broader national vision. Under Vision 2030 and our water security mandates, the country is committed to building infrastructure that safeguards public health and supports economic growth. Advanced wastewater systems are key parts of achieving those outcomes. Secondly, they help developers and utility partners meet the compliance requirements of agencies such as the NWC, Ministry of Health, and NEPA. By constantly producing high-quality effluent, these systems make regulatory approval easier and ensure that developments stay in alignment with national standards. Third, wastewater resilience is now climate resilience. Jamaica faces increasing drought conditions and pressure on our water supply. By implementing a reliable, adaptable wastewater treatment is critical for strengthening the country's ability to manage climate-related risks. And finally, safe water reuse is becoming essential. By producing effluent clean enough for irrigation, these systems help preserve our freshwater resources and reduce demand on the national supply, an important step towards long-term water sustainability. So the impact goes far beyond individual developments. This is about supporting Jamaica's national goals, protecting our communities, and ensuring a resilient future for the island. This slide outlines our strategic approach to deploying biomicrobics technologies across Jamaica. First, scalable deployment. We're focused on scalable deployments across three key sectors: industrial, residential, and commercial. This ensures that our solutions are acceptable, adaptable to various project sizes and needs, from large factories to small communities. Point two, strategic alignment. Our roadmap is aligned with Jamaica's 2030 vision and the National Water Commission's strategic plan. This alignment guarantees that our efforts support national development goals and water infrastructure priorities. Third, monitoring and resilience. Finally, we emphasize continuous monitoring and adaptive management. This means our systems will evolve with changing environmental conditions and community needs, ensuring long-term sustainability and resilience. In closing, this roadmap isn't just a plan. It's a commitment to transforming wastewater management in Jamaica through innovation, collaboration, and strategic foresight. So where do we go from here? As we wrap up, I want to emphasize that this isn't just a presentation, it's an innovation. Westpoint is actively seeking partnerships with government agencies, engineering firms, and developers. We believe that real change happens when expertise, policy, and innovation come together. With biomicrobic technologies, we're not just solving wastewater challenges, we are contributing to national resilience, environmental sustainability, and economic growth. So if you're ready to be a part of this transformation, let's connect. Whether it's a pilot project, a strategic rollout, or a community initiative, we are here to collaborate. Reach out to us today. Let's build the future of wastewater management together. Now, before I leave, I would like to show you all this video. I believe it's important because this is a MyFast 16, which treats 160,000 gallons per day. The facility is located in South Africa. It's built right next to the old technology, the old plant that was not producing, or rather polluting the environment. That there's your BMS zone. These are the blowers that are attached to the BMS zone. To your left, to your right are the blowers that enter the screening tank. These tanks have Lixor units to decrease BOD. As you see, these units are so the Asian side of treatment, which is this chamber. As you all, we have the fast units lined out, and the only moving part is adding air to them, and all these blowers are on top and easily accessible by maintenance crews. This facility only has one moving pump in the aerated zone that takes sludge from that chamber back to the BMS zone. The BMS could be considered to be a digester in similar systems. You thicken sludge, they become cannibalistic and they eat each other, and eventually you get a third-party cesspool service to come and remove sludge and dispose of it properly. So this is what a 160,000 gallon per day system looks like in terms of size and in terms of the layout. The guys in South Africa were getting exceptional nutrient removal from this system, as well as BOD, COD, and ESS removal, as compared to what they had or what they were using previously. So they had a 79% drop in ammonia nitrates, go below 5 ppm, COD 74%, phosphates dropped in 73%, as compared to samples tested from the old defunct plant. But here is where this video is important. This is the pipe leaving the system. So these collect the wastewater, the finished product from the treatment plant. I believe this tank stores some, whether it be for an irrigation purpose or to be used as sample collection for testing. But what is important is this. I just want you all to see what a biomicrobic system produces. Look at the quality of that effluent. That is drinking water quality. It's not drinking water, but I don't think you've ever seen another plant in Jamaica produce water that clear. And that is what this system provides developers, provides government agencies. It's a protection of our environment, and it enables us to provide additional reuse properties, which protects our water resources. That is the end of my presentation. I shall now put you all back onto Tanya.
Thank you, Mr. Cuthbert, for that informative and forward-thinking presentation. He shared Westpoint's vision for a cleaner, more sustainable Jamaica, where wastewater becomes a resource that powers growth and protects our environment. Through innovation and collaboration with BioMicrobics, Westpoint is shaping the future of water management and wastewater management and setting new standards for Jamaica and the Caribbean. Thank you, Mr. Cuthbert, for leading with vision and passion for Jamaica's sustainable future. We will now open the floor with our Q&A session. Participants are invited to submit their questions in the chat, and you may raise your hand if you wish to speak directly. Anthony and Tyler are here to answer your questions, and I will monitor the chat to ensure all questions are answered. So the floor is now open for questions as we begin this part of our webinar. So our first question here is from Mark. I'm understanding that the FAST systems are add-ons to the system for increased efficiency. Is my understanding correct? Or are these full systems? Also, are there specifications the system must have to accommodate these components?
I can answer that. So the FAST systems are, in fact, full treatment systems by themselves. So think of it as the FAST system itself refers to the actual media. The media itself is what's providing the treatment. But when you purchase, let's say, a microfast, you're purchasing a full treatment system. The only thing that is not provided by your distributor or by BioMicrobics itself is just the tank. We have a minimum tank size, and that's it. You just have to meet that tank size requirement for volume, and you're good to go. Everything else is a package system ready to be installed and ready to treat water. In terms of specifications for the system to accommodate these components, you just need electrical hookup and just that tank, and that's it. It can be installed above ground or below ground. Whatever fits your need best is what we can accommodate.
Okay. All right, so we have Mr. Lanford Chambers. I'm going to allow you to speak, sir, so that way you can ask your question.
Morning.
Right. I note. You have highlighted the different types of systems, and I was congratulated, although that very detailed presentation. But I have not seen the price range for the different types of system, both construction cost and maintenance cost, and also the duration or the life cycle for each of the various types of systems. Thank you.
Sure.
All right.
So in terms of cost, I only have the cost of what we supply to the distributors. The distributors are the ones who set the actual purchasing price for the customers. So I can't speak on that very well. In terms of additional costs for construction and maintenance, that's also going to be somewhat dictated by your local area. So if you're for instance, putting your FAST system underground, or you have an underground tank. However much it costs in your local area to remove that earth and put that tank in is what you're going to be looking at for earth moving costs. In terms of maintenance, the only thing you're looking at for maintenance for, let's say, a microfast system is just going to be that sludge pump out, which you'll be looking at. That really depends on your influent conditions and how much you're actually treating. It also heavily depends on your tank. So before, on my previous slides, we saw that the fast liner is somewhat suspended inside the actual treatment tank itself, whether that be it's standing on legs, holding it off of the bottom, or it's hanging from the top of the tank. What we say as a general rule of thumb, need about 4 to 5 inches from the bottom of that media where the opening is, where like the sludge passes through, to the top of the sludge blanket. We have seen like small tanks where they pump out once a year, every couple years, to people who get very, very deep tanks, like 8 or 9 feet deep. So that way they have hundreds or thousands of gallons worth of sludge accumulation, and they only have to pump out every 10 years or more. That really depends on the size of your tank and how much your local service provider is for sludge pump out. In terms of electrical costs, that was mentioned here as well. That depends on your model. So each fast size comes with a different sized blower. So for instance, let's say we're looking at a microfast 0.5. With that, you are looking at a like a 1/2 or 1 horsepower motor. So if it's a 1/2 horsepower motor, you're looking at about 0.375 kilowatts. So typically we advise to have that blower running 24 hours a day, 7 days a week, if possible. Some places, because of electricity costs and because of the flow conditions, whether they be intermittent or there's just periods where nothing's coming in or very little is coming in. For example, that one site that I said I visited in Tennessee, they have very little influent flow between the hours of midnight to 4 or 5 a.m. Those blowers actually have timers set in them. So you can say, I do not want this to run between these hours. And it's as simple as lifting a switch. There's switches in there corresponding to, I believe it's like 30-minute increments. You just lift those switches up so that way they do not make electrical contact and the blowers automatically shut down during that period. So that is an option for cost savings for electricity, if that is something that is of a concern. Because I do know that electricity costs, specifically in Jamaica, are relatively high. Anthony, are you able to speak more on?
Yes, yeah, Mr. Chambers. As Tyler indicated, pricing is specific to the development requirements. So generally how the process starts is you will contact us and we would ask some simple questions, how many houses, try to work out a per head population for your development. And then we determine a peak flow rate expected to be coming to a plant. So in terms of providing a chart of costs, it's kind of hard because every development is different and they have so many. If you look at Tyler's list, there's so many ranges that the factory makes. And then you have the ability to include them modularly. So you could take a microfast 9 and put 3 of those units to get 27,000 gallons of treatment. So the price of construction goes up, obviously, with the concrete tanks, the amount you have to build, or the volumes, plumbing. But when you buy a microfast system or anything from BioMicrobics, it comes as a package system. They send valves, they send pipes, not pipes, they send valves, units, all the major accessories come as one package system. The only thing that I've known you have to buy locally is pipe and tangent. And it's a start and go. The HSMBR system is a little bit technical, as Tyler mentioned. That system comes with a panel that, well, the 2 HSMBR systems we have installed here, the one at Besser and the one at Portnoy 2. Those panels run the blowers, so the blowers are on timers. Those panels run the mixing pump, which is a 0.5 horsepower. It runs the return pump, which is a 0.5 horsepower. And it runs the effluent pump. And the effluent pump stays above ground and it sucks water through the membranes and discharges it to the soak-away pit or the effluent storage tank. That's a 0.5 horsepower. 7.5 horsepower blower motors. They have 2 power mixing motors, 2 0.5 horsepower return pump.
Something else which I forgot to mention is with the blowers. So even though we may be installing or providing a 0.5 horsepower blower, typically these blowers do not operate above 75% capacity. So that 0.5 horsepower blower, which is 0.375 kilowatts, usually will not operate above 0.28 kilowatts.
Okay. We have another question here. We have another question here from Craig. Very well presented and informative. Concern I have is the power consumption of the systems. Is there a general idea as to how much kilowatts per hour is used by these systems? Can solarizing these systems be optional?
So I touched briefly on the power consumption. So let's referring back to that microfast 0.5. If we're running it at maximum capacity, that's 0.375 kilowatts. If you're running that for 24 hours a day, you're looking at about 9 kilowatt hours. And that's at maximum capacity, which is not typical. What's more typical is about 75% capacity, so that's 6.75 kilowatt hours for 24 hours a day. And then again, you could go further into limiting when the blower is actually operating, if that is a desire. In terms of using solar, I actually have no experience with that. That's a very good question, though. I imagine as long as you have solar panels, which are capable of putting out that much power, and the sun is willing to cooperate with you, or if you have like a battery bank which is charged by solar, that could be an option. I'm not too familiar with solar, but that is an interesting prospect to consider. That's not something that we currently offer, whether it be like solar panels or like additional battery banks or anything like that, but it is something to consider. That would have to be on whether the distributor offers that or it would have to be on the client's own initiative to establish any sort of solar power for these systems.
Okay, Mr. Lanford. Mr. Lanford Chambers, you can go ahead and unmute. Following Gary Willoughby. Gary, your hand was up. Did we lose Gary? Seems we did. All right, Mr. Willoughby. It seems we've lost Mr. Willoughby. His hand was up though. All right. Oh, okay. Craig, go ahead.
Unmuted.
There you go. You're unmuted. Good job.
Okay, you're hearing me, guys?
Yes.
Yes.
Okay. All right. Again, very informative presentation. As someone who was involved with environmental protection, I think that this is the way Jamaica really needs to go. You know, more developers need to really consider this type of system in protecting our water resources. I have a question more directed at Tyler. Currently, as a designer, as an architectural designer and developer, I am currently looking on a commercial site that would have some level of industrial processing. And the processing I'm referring to is more geared to light manufacturing for like food processing, that sort of thing. Is this system a system that could be considered to
Yes, this
out
is
of a commercial space?
absolutely it is. So I am currently actually working on a project which involves a client who does do food testing for a lab. A lot of the waste that they are producing is very, very high strength, probably some of the highest strength waste that I've ever seen. And from some small scale tests which we have conducted here in the lab, we have shown that we are able to treat it with our systems. So I would need a little bit more information to know if this would be like a high strength fast situation or if this would be a biobarrier situation. But commercial property, no problem. Any sort of like food processing, production, anything like that, depending on what's in the water is going to kind of dictate our treatment solution here, because we have to make sure that we're okay for like the pH, BOD loading. Other things which could be considered would be any sort of inhibitory compounds which may be in the water. By inhibitory, I mean hopefully not like lead or arsenic or anything like that, but that's always something to consider because those sorts of compounds can be detrimental towards your water treatment efforts. But yes, we have designed solutions and implemented solutions which are currently in operation and are currently still treating wastewater to this day in facilities similar to the one you have described.
Okay.
And Craig, just to mention to you, BioMicrobics also makes a line of grease interceptors called fog hogs.
Okay. So that would
So
be
if
more for like restaurants and so forth.
yes, if you have wastewater that is coming into the plant that has a high fat, soil, and grease content. BioMicrobics has grease interceptors that they've also designed. We never spoke
Oh,
about that much today, but that's one
right,
of the
right.
products that they have in their arsenal.
Okay, okay, okay. Good, good. Um, to you know, Mr. Cuthbert, in the planning process, I think I had reached out to you some time ago of a commercial area that I'm currently dealing with, and with trying to sell this product to the client. They are in the States, and you know they are environmentally educated, so to speak, and it wasn't really hard to sell this concept to them. But in terms of a quick sizing method, is anything in place for like designers like ourselves to have something available to us that we could say, all right, Westpoint can do the detailed designs, what needs to be put in place, but at least give us some information that we can quickly have meetings with our client, say this is what we think could be recommended, and Westpoint will go ahead and do more work in getting it detailed out. So at least we can probably say to our client, based on a quick assessment, we think that you would be spending, say, $1 million on a sewage system or $2 million on a sewage system, that type of conversation that we could have with our clients so they can align their budgetary constraints for their project.
And the answer is yes. What Westpoint offers to clients is once I get basic information about the development, I guess, again, as a wastewater engineer, as an environmental engineer, what we're trying to do is determine that queue that's going to be coming in to the facility.
Yes.
That flow rate determines the size of the plant. So once we've determined what we need to treat that quantity of raw incoming waste, we could quickly get a quotation from the factory as to what the equipment costs are like. My apologies.
Yeah, man, no problem.
So as part of design, Westpoint, you know, once somebody decides they want to use a system, we will provide those dimensions and specifications for the concrete reactors. We will tell you sizing, steel, reinforcement, the penetrations as to what height you need to place them, because you only need to understand that a lot of these systems work by gravity, meaning there's no pumping from the settling chamber to the aerated chamber. Everything flows by gravity. So that's how we're able to cut down on maintenance costs, because there are less moving parts in a system. So yes, we also assist with permitting, sending documents into NEPA to be approved. And then we offer construction help. We could work with your people on the ground, or if you would like us to come in and build it ourselves with our team, we offer that as well.
Okay. All right. Sounds good. Gary. Sounds good.
All right, we have Mr. Lanford, your hand is up. Do you have another question for us? Oh, here we go. Sorry, I had to step away for a few minutes. It would be good to prepare a brochure that outlines the different systems and the price range for residential up to 4,000 and commercial solutions. Government think in terms of numbers, as this is also This is critical in decision making. We do have brochures, and I would be more than happy, Mr. Lanford, if you just email me, I will send you the details. So that way you'll have those on hand. All right, Mr.
Okay,
Willoughby, your
okay.
hand is up. I know that the internet nowadays right now is kind of shaky for quite a few people, so just unmute your mic, Mr. Willoughby. Did we lose him?
Are you hearing me?
Yes, I'm hearing you now.
Finally. The quality of my internet is really poor, so forgive me. But first I want to say really good presentation. Very well done by Taylor and Mr. Cuthbert. I have a question about cost. So my question is, how does the total cost of ownership? I know there was a previous question about cost, but I want a more comparative analysis, basically. So how does the total cost of ownership for a biomicrobic solution, when you factor in installation, operation, life cycle costs, compare to other systems on the market?
Well, any other competitor, you're getting into, besides, all right, let's start off with, besides pond systems, which require acres of property to achieve treatment that is naturally occurring. What we are promoting and selling is mechanical systems. In terms of our competitors, our systems have less moving parts. Less moving parts equates to less power consumption requirements, which reflects into savings. Because of the robust nature, especially of the fast line of treatment alternatives, maintenance now is a lot easier than conventional racetrack systems or sequence batch reactors or other types. Because again, the modules are fixed. There's no reason to pull them out, or there is no maintenance. As Tyler said, it's build it and forget it. That's how the systems operate, but you still have to maintain it because the maintenance comes into the scale of sludge removal, like a typical, anybody who has a septic tank, anybody who has ponds, they're gonna have to desludge from time to time. So with the fast line, sludge removal is one mainstream maintenance item. That is also in line with the BioMicrobics HSMBR system. These systems have a settling chamber. The settling chambers collect all the inorganic stuff, the papers, the toiletries, the other inorganic materials, and prevent it from fouling up downstream pumps and mixers. That settling chamber needs to be cleaned. How often is that? That depends on, every development is a fingerprint. Every development is different. Some developments produce more or a larger quantity of inorganic materials on a daily basis. Some don't. It's just, so that's where maintenance comes in, is having somebody open up that chamber, take a look to see the scum line, see how it looks, and then determine from that visual whether a cesspool truck is required to come in and do what it does. With the HSMBR system, there's a little bit more in-depth maintenance, because the system runs on a control box that has timers set for the blowers, the filtrate pumps, the mixers, and the return pumps. Operators need to understand how to configure certain elements in those boxes into the interface. So there's some training to understand how you get to the sections in that interface to adjust times, voltages. So whereas the MIFAR system is a lot easier maintenance-wise, HSMBR, which gives you a lot better quality effluent, or a lot superior quality effluent, requires some training because of the operational interfaces in terms of the control panel. You need to be aware of a vacuum gauge that they give you, and you have to look at where that gauge is registering during the filtration mode, and if it's below a certain threshold level for a long period, it means that the membranes are going to need a clean in place procedure, which involves opening up the valves and pouring a citric acid solution into the membranes to declutter them and get them back working as originally designed. So the MIFAR system is pretty basic in terms of maintenance. As part of my presentation, I showed you all that video of a 160,000 gallon system in South Africa. Basically, operators have no reason to go get their hands in wastewater. Everything is the blowers up on top. And for the BMS, which is the biomanagement zone, which is a digester, it's just a matter of connecting a cesspool 3 or 4 inch hose to a quick disconnect on that tank and sucking that tank down and taking that sludge out or away from the site to be processed at another facility.
Okay.
All right.
So
Sorry. Continue,
can
Gary.
I just, yes, because his answer kind of feeds into another question that I had. So no, my first question about cost, but my second is about competitive edge. Based on all that, I've heard, just to, put a finer point on it, could you just say, bullet even, what differentiates BioMicrobics then from other treatment competitors, particularly when it comes to sustainability, proven performance, and even local support?
Well, I guess the biggest advantage, especially for developers engaged in medium-sized developments, a lot of land or expensive land is being purchased up in Kingston and St. Andrew, in Ocho Rios and Montego Bay, Negril. As you all are aware, an acre of property in these prime areas are pretty high. A standard system utilizing a reed bed takes up a lot of space that could otherwise be used to enhance the cost of a development. So by using a biomicrobic system which incorporates a smaller footprint, some of these systems require no reed bed for nutrient removal. If the system was to get a irrigation system as part of amenities for the development, the plant provides a source of water for that cause. So just by land saving and giving the developer the option to take this piece of land that would have been dedicated to a reed bed, they could put additional parking. They could put a swimming pool. They could put a pickleball court. They could put a clubhouse. It's infinite what can be done with a sizable piece of land that a reed bed takes up. I believe that alone adds significant value to some of these smaller developments where land is a problem because they're buying small acreage and they're trying to maximize profits as best as they could. And to maximize profits, you need to sell more houses. As I showed in my presentation at Port Oil 2, the phase 1 of that development, the reed bed is almost the size of 1 block of houses. Imagine having the ability to use that land space to build another block of houses. It just adds on to the profitability of your development moving forward.
All right, thank you very much. Once again, this was a very, very well put together webinar, very informative, and it serves the interest of. Thank you. Thank you.
Thank you very much. I think that is it for all our questions at this time. I just have our closing part of the presentation. And so that way we can close out at this time. All right, so this final slide here brings everything together. A clear, actionable roadmap for how we move forward. Our approach is designed to be simple, efficient, and collaborative from the very first step. So step one would be to contact Westpoint. To begin, reach out to Westpoint. Your main point of contact is Anthony Cuthbert. His phone number, email, and direct link to our contact page are listed right here. This is your first step to formally initiate the process and start building momentum. Once contact is made, we'll gather essential project information, things like the location, the expected capacity, and the intended use of the system. These foundational details enable us to tailor the solution precisely to your project's goals. Next, Westpoint takes the lead on submitting the commercial inquiry form. This ensures BioMicrobics receives all data needed to begin engineering and pricing work without any administrative delays. At this stage, BioMicrobics engineering team develops a customized design aligned to your project's requirements. You'll then receive a formal proposal with detailed system specifications and transparent pricing for your review and approval. Through your partnership with BioMicrobics and with you, we're advancing innovative wastewater technologies that directly support Jamaica's growth and resilience. Our shared commitment to excellence, sustainability, and service defines who we are. And together, we're building a cleaner, stronger, and more sustainable Jamaica. I would like to thank everyone for joining us today, despite some of our internet issues. I'm happy you were all able to join us today. I would like to also thank our keynote speaker, Mr. Tyler Birch. I do appreciate your time and information shared with Jamaica. And Mr. Anthony Cuthbert, thank you so much for your expertise and answers throughout the Q&A session. Everybody take care. Thank you very much for joining.
Thank you very much, everyone. Have a great day.
You too. Take care.
Thank you very much, everyone.
All right, thank you. Thank you for the detailed presentation. All right, we'll definitely be contacting Mr. Cuthbert.
Thank you so much, Mr. Chambers. You have a wonderful day.
Yeah, thanks. Same to you.